Hi class, in the next set of problems we're going to be looking at graphs of fractions, and let's take a look at the first problem. So in the first problem they're giving us a line segment. I'm putting the arrows because technically the line segment goes on to infinity, and they want the position of two values. So technically they want this given value here and that one. Now, we have to count how many equal pieces they're actually giving us. So in this case, I see 1, 2, 3, 4, 5. So technically the values of 1 is expressed as 5 over 5. So therefore, well, the values of A, it's going to be 1/5. And then B, it's going to be 3/5. And let me just write it here as 1/5 and 3/5. So you're just counting the total equal pieces that they're dividing the integer of 1 and then counting from there on. So once again, A is 1/5 and B is 3/5. Let's take a look at another problem. In this case, on problem 2, let me put the arrows. So you can actually see that B is 0. That one's actually given, but let me count the pieces of the line segments between 0 to 1. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So technically 1 is given as 10 over 10. So therefore A is equal to 1/10. And let me just we'll write it out as A is 1/10 and then B is actually 0. That's it for that one. Very similar to the previous one, except that here they're cutting the pieces into, well, they're cutting the integer of 1 into more pieces. Let's take a look at problem 3. And then let me start dividing some of these. Actually, not dividing. What I mean is simplifying. So for example, 0 divided by 6 is equal to 0. So when you're graphing on the number line, you're technically putting the dots. So that's why on the previous one, I put a dot on 0. And same idea on the previous one, I put a dot on B. Here they want us to actually identify the actual pieces. So technically for 0, we would put a dot there. The second value is 2/6, and then in this case 1, 2, 3, 4, 5, 6. So that this would be 2 6s, and I'm just putting the dot there. Then 5 6s, so that's gonna be this value here. Then 6 over 6, it's technically 1. So let me just write it out as 6 divided by 6 is equal to 1. And this value of 1 is here. The last one would be 9 6s. So this would be, well, 1 is equal to 6 over 6. So this will be 9 6. And then your final answer is technically the dots on the number line. So we're referring to it as, well, technically that dot, this one, the 5 over 6, technically the integer of 1, and then the 9 over 6. And that's actually all they want for this problem. So don't forget that when you're graphing on the number line, it's the dot that matters, not the slashes. Let's take a look at problem 4. And in problem 4, they're asking us to express the shaded region. Notice that the actual integer of the square, it's being broken up into 9 pieces, and I see 5 of them being shaded. So in this case, it'll be 5 9s. For B, it's broken out into 4 pieces. So one of them is shaded, so that would be 1/4. Let's take a look at problem C. In problem C, it's also cut into 4 pieces, but you only have 3 shaded, so this will be 3/4. Let me count the ones for D. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And out of the 12, 1, 2, 3, 4, 5. So 5 out of 12. And let me just box in my final answers here. Let's take a look at problems E and F. And E, I see that they're cutting the squares into 1, 2, 3, 4, 16 pieces. And then out of these, 9 of them are actually shaded. So it'll be 9 over 16. And then for F, let me count the pieces 1, 2, 3, 4, 5, 6, 7, 8. And then out of these, 1, 2, 3, 4, 5. 5 out of 8. Let me box in the final answer. And let's take a look at G. In problem G, you can express this as technically 1. And then the second portion, it's gonna have, well, 3 out of 5. So you can express this as 1 and 3/5. We can express it as a mixed number. Let's take a look at H. This is gonna be 1. And then I see 9 pieces, but then just 2 out of 9. So 1 and 2 nines. And you can also express it as an improper fraction. They don't tell us exactly how they want it, so I'll just leave it as a mixed number for these two problems. Let's take a look at problem I, and I see 9 pieces, but out of these, 5. So 5 out of 9. And then technically, this would be 2. There's 2 integers, and then 3/4. Let's take a look at problem 5. Okay, so problem 5, we have to be careful because they're telling us that all the collection of the actual circles represents 1 unit. In this case, well, they're out of 1. So I count a total of 1, 2, 3, 4, 5, 6, 7, 8. And then technically 4 are actually shaded. So this particular one, you can express it as 4 over 8, or you could actually reduce it. And to reduce the fraction, you're actually canceling common factors. So 4 times 1, and then 4 times 2. And then here, your 4's cancel. So this particular one, the most proper way to express it is as a half. Or another way you can view it is, out of the 8 circles, which represent 1 integer, half of them are actually shaded. So the proper answer here would be 1/2. If you're working on a software problem, and if you were to put it 4/8, it may mark it incorrect and it say that your answer is not in lowest terms. We'll be simplifying fractions later in this module, but that's actually it for these problems.